Wheeler. All right, here we go. All right, welcome to a double slit 4 quantum eraser home version where we'll learn how to do this, one of the strangest experiments ever done in physics at home with just things you might find around the house, except one thing you might not easily find around the house, you might have to order. I'll do this to reiterate one of the strangest experiments in physics and describe it again. So there's 3 other double slit lectures you've missed already, and there's more coming in the future. So this is really strange stuff at the root of physics and the strangeness of physics. So I am Robert Nemiroff. I'm professor at Michigan Tech, and this is the obligatory second slide that says what this is. You can read this. You can get the lectures any number of places. This is a real course. So let's jump into it and say this is based on something that I didn't realize it was so easy to do at home. This is a Scientific American article, a fine magazine, by these 2 people who came up with this idea. Rachel Hilmer and Paul Quate, who I don't know. They realized you can do a lot of this at home and very simply. So I'm going to step people through this. So you can, if you don't believe me, if this stuff is too strange for you, you can try to duplicate this. So first you need a laser pointer, which are surprisingly common these days. They're giving them away at conferences. They used to be expensive and prized back when I was a wee lad. Now they give them away. You can surely find one almost anywhere. Here's one. I think it's part of a keychain. Don't stare into it. All right? So take the ordinary laser and point it at a wall. If you should get a spot, most commonly a red spot, but now they can be other colors. If not, then try a laser that actually works. Okay, next a pin. These pins are not hard to find. They're stuck in shirts that hurt you. So the next time you're putting on a shirt, if you're a guy, and just take the pin and put it somewhere where you can then use to confound quantum mechanics. So you then place this pin between the laser and the wall, and what would you expect to see? Would you expect that you would see an interference pattern on the wall? Would you expect no interference pattern? Or would you expect that you would now suddenly fully understand quantum mechanics? And the answer to that would be an interference pattern. So a pin is sort of like a poor person's 2-slit experiment, because the laser itself does not have that wide, I'll do red because does not have that wide a spot. So if you were to take a pin, it's sort of like having slits of this width here. Technically the slit widths are infinite, but because the laser spot isn't that, you're not going to have lots of other bad integrals to do because you have to merge this part with this part and this part with this part. It's pretty close to a 2-slit experiment, and you can just do it right there on the wall with a pin. All right. Next, here's the harder part of things to find. You want to find a plastic sheet that polarizes light. You can find these on the internet. You might try eBay. You can try sunglasses, but you might find an old pair of polarizing sunglasses and you'd have to break them. So borrow your friend's sunglasses if you have to do this, and then claim to have misplaced them later. But if you just do this with a plastic sheet, it's easier. You can just cut it with the scissors. So you cut the sheet and repaste it. So this sheet, let's say, polarizes light in one direction, say horizontally. So here's your sheet here. So light that comes in here, let's say, is all zigzaggy, but then it comes out in one direction. So now you want to cut the sheet in half and then reattach it so that here's your sheet. Now the pin is here, not drawn to scale. Here's the other sheet. So this sheet is creating polarized light like this, and this sheet is creating polarized light like that. Now, many people haven't seen the last lecture, so I'm going to pretend you haven't seen the last lecture, which would have given away a lot of this. So now you put the pin between those 2 sheets and you shine your laser on it again, which I can now do in spectacular red, nice big. And before you saw on the wall, you saw interference pattern fringes. So again, let's diagram this in blue because I think I have more time this time than last time. So you have your laser here, you have your slit screen here, and you have your image screen there. Slit for slit screen. image for image screen, and the laser throws off light, and you effectively, in the previous version, for sure, before you deployed your polarizers, you would get an interference pattern, which I will show like this. Now you put on your polarizers, do you still get this one, or do you get something with two humps, essentially behind the slits, that is a no interference pattern? So I think I ask, so what do you see? Do you see an interference pattern? Do you see an illuminated pin? Or do you see Casper the Friendly Ghost? And drum roll, please. You see no interference pattern. So these polarizers wipe out the interference pattern. So the laser light's still going through. On the one side of the pin, it's polarized one way. On the other side of the pin, it's polarized the other. They don't interfere anymore. So when you look at the slot at the wall, you don't see the interference pattern. The ups and downs go away. You see essentially the shadow of the pin and then bright spots on either side. That's partly, but more than partly because you now have which way information. You now know that theoretically, if you were to sit there with a polarizer, you could figure out which photons went on which side of the pin, and that will break the interference pattern. Which way information breaks the interference pattern. Okay, said enough. Third polarizer. So you still had part of your sheet left, your large plastic sheet. You now take this sheet and you orient the whole sheet so that it, let's see, find another large, orient it vertically, hold the sheet between the slit screen and the image screen, making sure that all of the laser light hits it. Okay, so this is, okay, I put an intermediate step. Fooled myself almost. So now you have laser light here. You have your slit screen here. You have one side creating horizontal polarization, the other side creating vertical polarization. No, that's wrong. I just changed that. Sorry. They both, is there an eraser? There is not. Undo. Oh, yes, there is. So you now put the same one on both sides. So what do you see if you now have them all given the same polarization? What do you see on the slit screen? Do you see an interference pattern or just two humps? That didn't go right. Let's undo that. Just two humps. And the answer is illuminated pin. The neighbors are wondering what's going on. No interference pattern. No, wait. Third polarizer. Oh, okay. I think I described a different experiment. Okay, so let's back off. So these were then, I got it wrong. I've been a little while since I made up this slide. So here you put a third slit one here, and this is going to wipe out one of the interference patterns. So you're only going to get half the slit illuminated now, because this is one way, this is the other way, and if you go through two polarizers, one vertical and one horizontal, you get no light coming through. But this one is horizontal both ways, so it allows all the light through. So that means you only get light coming from one side of the pin, which means that you only get one of these. So you get no interference pattern, you just get one side of the pin illuminating. The other side of the pin does not illuminate. I apologize for the previous misstatements. So now you're going to take the third polarizer, and you're going to rotate it by 45 degrees. So again, here you have your laser. Here you have your pin. On this side, you have a horizontal polarizer. On this side, you have a vertical polarizer. And now, let's put the pin in black. Hello. Let's make the laser light red. Okay, so now you have your slit screen here, and you have another polarization sheet here, again in blue, and it's going to rotate whatever it is by 45 degrees. Now you notice if you rotate this by 45 degrees, you get the same thing. You get this, and if you rotate this by 45 degrees, you get this. So what this is going to do, what this other polarizer is going to do, it's going to make the photons going on both sides of the pin have the same polarization. So now, over here, they had different polarizations. These were horizontal, and these were vertical. past the next plastic sheet, they again have reconstructed. Now the same polarizations. They're now 45 degrees. So if this wasn't here, you had an interference pattern. But now that you put this one in, what happens? An interference pattern, no interference pattern, an unlimited pin, and the neighbors have called Ghostbusters at this point. You get an interference pattern. This is the home version of the quantum eraser. Previously, when you had one being horizontal, one being vertical, you had no interference pattern because you could tell which side of the pins they went. Now when you put in the third polarizer, all the photons are once again indistinguishable. And so when they're indistinguishable, you get an interference pattern. So you've erased the which way information, which is why this is called a quantum eraser. So it turns out you can erase information. And you can do this at home with just pins. You can erase and unerase quantum information as much as you want. And you can see that your choice as to whether to put that in there will determine whether you see it or not. And now I'll go to, again, the kicker, which is, let's say you had delayed choice. Let's clear this. Let's say you could have done this at a time. Now, if you just use your regular laser pointer, the laser is moving so fast and the distances are so small that you're not going to have the ability to do this. But they have the ability to do this in the laboratory. That the photons can then come off in a bunch. The laser gives off a bunch of photons. And that's it. And those photons can pass the slit screen. They can be horizontally polarized here, negatively and vertically polarized there. Then you can have a delayed choice after the photons have passed the slit screen. After that, you can choose to put in this last polarizer. And if you put the polarizer in, then you lose the information as to which side of the pin the photons went on, and you get an interference pattern. If you choose not to put that third polarizer in, this is the third polarizer here, then you get no interference. So even though the photons have passed the slit, you can decide whether you see an interference pattern or not by putting in that third polarizer. Again, you can't do this at home because they move too fast, but it can happen in the laboratory, and it has been done in the laboratory, and it's been determined. So with that, we're going to get to even stranger stuff, well, a little bit stranger stuff next week with something with other types of two-slits experiments involving something called entanglement and other aspects of this. And so there's some really strange two-slit type experiments still yet to be done. So if you think you understand even this, wait till the next lectures and they'll be even stranger. So with that, we'll wrap this up. Thank you. See you next time.